back to the internet from whence I came for another stream of Odinmade Hero. I am very late today. It's been a hectic day, but a good day, I would say. Productive and crazy, but starting off super late, so I'm just going to jump right into day 31. Make sure that I'm actually live on Twitch and YouTube. Had to take a shower because I was getting pretty stinky there, and so having to kick off the stream, you know, with my hair still all wet, which is a not great feeling. But if I was gonna have any time to stream today, it was gonna be now, and I'm already late. So let's just go ahead and jump right in. Get going with some code. I had some notes, but there's just no time to go over them from yesterday's Q&A, so we'll just save those for tomorrow, maybe, if there's more time.
Okay, everyone, welcome to Handmade Hero, day 31. This, of course, is the show where we program an entire game from scratch, live on the air. And of course, the reason that we're doing this is because I think it's just a good idea for everyone to have the experience at least once of writing a game from start to finish, so they know how absolutely everything works in the entire pipeline of a game. It's very empowering to do this because it means that you never have to be restricted again by something that someone else wrote. You can always choose to go write some portion of an engine or some portion of a library yourself, or even the whole thing yourself if you were so inclined. But it also means that even if you're just using things that other people wrote to build your games, you will be able to know how those things themselves work. And so that actually makes you a much better programmer as well, because you can do things like understand the performance implications of the things that you're doing, and that can help you even when you're using like an engine that somebody else wrote. So I think it's a great thing to do, and I think people have been enjoying it. I have certainly been enjoying it. So with that in mind, I think it's a good time to go ahead and get started here. Let's see. If you are following...
Oh, the one thing that I guess I can say is that during the Q&A, one of Casey's viewers recommended that... Actually, it wasn't that. It was this. That the X and Y of the canonical or the world position were designated as the tile relative X and Y, which is, you know, the extent to which we are inside of a given tile by the X and Y coordinates and floating point. And so I just went ahead and made that change to stay consistent with him, and off we go.
Along with the source code at home, which you can do on handmadehero.org. If you go to the pre-order button, if you've pre-ordered it, there should be a link that came to your email that you can click on and download the source code. I update it every night after we finish coding, and you can open up that link and you can download a zip file. Inside that zip file, there's a zip, like a sub-zip for every day. Since we're on day 31, you want to start with day 30. You always start with the previous day. So if you unzip day 30 into a directory and start coding in that directory, you will be exactly where I am today when I am starting, because that is the source code that I am starting with as well. Now, where we were when we stopped last week is we were actually at the point where we had our little yellow rectangle that we were basically using as a test for the player moving around a little gray and white rectangle, sort of blobby tile map placeholder. And we were just verifying that we could do some very basic things like move him around the tile map. We could have doors that he could walk out of, that sort of thing. And, you know, nothing particularly fancy, but again, what we're trying to do here is explore the code a little bit and basically figure out what sorts of things we're going to want from our engine so that it supports the game that we're trying to make cleanly and doesn't involve, we want to basically avoid going and writing an engine without any knowledge of what we want it to do, because we'll probably be liable to make a lot of bad decisions. So what we're basically doing here is trying to get down to what are the exact things that we need the engine to do and how we want them, how we want it to do them, so that we can then go implement the engine and do it in a nice, clean, concise way that does exactly what we want and that will be very convenient for us to use. So what we've gotten ourselves to at this point is a very basic thing where we can sort of do what we wanted to do with the tile map, and we can sort of check for collisions and do that sort of stuff in a very basic way. But there's a bunch of things that we should probably talk about here, and there's also a bunch of things that I want to sort of bring to your attention about it. Before I do that, I do want to talk about one thing briefly, because it had come up a little bit on the forums over the weekend, and I just wanted to sort of clarify some stuff for people, just in case they were concerned about this. So obviously, I've said before that like the design is not really part of the stream. So we're going to be making the design that I designed. And that's just the way it goes. I'm not a game designer, so I'm not going to teach game design on the stream. I couldn't even if I wanted to. So basically, the design is just the design that I have, and that's what we're going to do. But so people were concerned about the fact that I was saying that my design calls for the game to basically be a locked screen, and you walk off just like the old Legend of Zelda. Now, I could defend my design decision to do that, I think, very well. I think about design things a lot. I'm not just an arbitrary person. And for people who think that that is not a good idea, I have plenty of things I would say to challenge that notion that you want to have a scrolling backdrop But, like I said, the design's not up for discussion, so I don't really want to get into that. But what I do want to do is say, if you are concerned because you would like to see how to implement scrolling, because maybe you have a game idea that would involve a scrolling backdrop, that is totally valid. And so what I would like to do as well while we are doing this is just show how there really is no difference between these two things, and that I'm just making basically a game design decision to keep this locked. But I will be able to show you, I think in just a couple days after we sort of finish our tilemap exploration here, I'll be able to show you how to basically just turn on scrolling in a sense. Because scrolling, if you do the things that I want to do with the tilemap, if you support all the things that I want to support, you get scrolling for free. I just won't be turning it on because I don't want it like in the game, but it's actually for free. And the reason that I say that is because I don't want there to ever be any loading screens or hiccups when you're playing this game. And what that means is that when you move, when the little yellow rectangle moves off the side of the screen, so if he comes down here to the bottom and he moves off the bottom of the screen onto the next screen, there's not allowed to be like a pause there or anything. It has to immediately show whatever that bottom screen is, right? And so I'm assuming that our engine will always be able to draw basically the screens that are all, the 8 screens that surround the one screen that we're on. It would always be able to draw those at a moment's notice, right? Like instantaneously on the next frame. So if you wanted scrolling, it wouldn't really be a problem because all you would have to do is actually just go ahead and move the camera over and ask it to draw, part of that one tile map and part of the other tile map, and you could have a smoothly scrolling game with no problem. So I don't want anyone to think that our engine will be any cheesier because of the fact that it's not supporting scrolling. We will be doing no cheese. It is a cheese-free zone. But yeah, I just don't want scrolling because there's a number of things in games now that I want that are specifically prohibited if you have scrolling. They won't work as well. And so I'm not going to do scrolling. But I will show you basically how to turn that on because if for some reason you're concerned about the technology, we are totally writing an engine that would have been able to scroll if it wanted to. I just don't want it to. So with that out of the way, let's talk about the next thing that I wanted to sort of get into.
It's funny he goes on about that because I'm pretty sure we get smooth scrolling just by default for a little bit, and then it might go back to that screen-by-screen transition. Can't remember, but it feels like it just winds up being smooth scrolling for a while. I think it's interesting just how much of a difference that sort of thing does make on the actual game's design. And all of this stuff with tiles over the last few days of programming on this project, I was thinking to myself, what about like a tile-based, turn-based game, more like Final Fantasy Tactics or what's another one? There was a game by the same people that did, I think it was Battle Block or something like that, where it was turn-based, and I think I played like a beta of that, but I never really touched it after that. I can't remember the name of it, but it's just interesting how looking at some of this stuff kind of makes you start to think about the actual design of the game and how the implementation kind of informs what design, or rather the design informs the implementation, but I'm still working on trying to acquire that more nuanced understanding of these things. It's not obvious to me, like if I wanted smooth scrolling or not, like he'll show it here before long within, the next few weeks of programming on this thing, that it's really not that difficult to change the way the camera moves, but that does have an effect on the gameplay quite a bit if you think about it. And so maybe then again, the design doesn't necessarily have to inform the implementation all that much. It's all about context in the end anyway. So what's the point in bike shedding it?
Into here. So what I want to talk about now is I want to start talking about, we notice we've got this to do in our code, which was math functions. I used the floor f function. And previously I used another function. I used sine to make the sine wave that we outputted. I don't know if you remember that, but basically up here at the top of handmade.cpp, when we were using our test sine wave, I was calling sine f to compute the sine of a value and that sort of thing as well. So really, I would like to finish up doing the tile map stuff right now, Monday, Tuesday, Wednesday, but really I think these things are sort of going to go hand in hand a little bit. And so what I would sort of like to do is just pause for a minute and talk about kind of all of the stuff that we're going to have to deal with, and sort of the math function stuff as well, and how we're going to deal with that stuff, because we're kind of getting into a part here where we're going to have math functions, and we're going to have a bunch of different things that we want to do. So here's the status. First of all, math.h is the C runtime library's include file. So this is something that ships with any version of C, right? It is the C runtime library include file that has a bunch of functions that you would need if you're going to be doing basic floating point mathematics operations. So I don't know if I can find a simple reference right here. Yeah. So this is an example of the functions that are in there, right? And they look like the kind of things that you had in high school trigonometry class, assuming that you have had high school trigonometry class. I don't know if there's some youngsters on the stream, then they may not have. But basically, they're the things that you would expect from there. Cosine, sine, tangent, arcsine, arctangent, and arctangent 2. Now, arctangent 2 is a better way of computing arctangent, and we'll talk about that a little later in the stream. But basically, this is the inverse of the cosine, inverse of the sine, inverse of the tangent, inverse of the tangent in a different way. These are basically just the things that you recognize from trig. And
it's so interesting because I know I've heard the creator of Odin in some of his streams say that he doesn't really care to use a language server. He'll just pull up documentation. And of course, he has all of the source code for Odin, including its math package, inside of his Odin directory where he works on the language. So he can always go in there and just look at it. But there's just something that feels very nice about being able to jump out of my own source code and just start looking at the code. And then I'm just using it like documentation anyways. And in that sense, like, I always feel like the code it tends to be the best documentation because we try our best with language, and I was talking about this yesterday. But we try our best with our words to articulate what it is we mean, and so often they just fail us. If you're really good at articulating things with your words, then maybe you don't have that problem, particularly if you're able to sit there and think about it. But this gets even worse when you're having a dialogue with somebody about something and you're both just kind of thinking and reacting to what the other is saying. And so then it's no wonder that if you're, getting in arguments on Twitter or Discord or Reddit or wherever about doing a thing and you're just flying off the handle and reacting to everything you see, when not only is it hard enough for you to articulate what you mean to this other person via text, it's just as hard in the reverse, or harder for you to understand what they're saying because they're having a difficult time. It's just, I don't know why I go off on this tangent, but it's so important to think about what language is actually good for. And these are kind of the themes that I want to try to grapple with if I can ever get to a point where I feel competent enough to design a game that I can actually go and build, that's realistic. Yeah.
We don't care about the hyperbolic ones, but again, they're the same as what you would find in mathematics textbooks. Similarly, coming in here, same sort of stuff you were used to in your high school math. You can exponentiate things. You can take the log base 2, log based, I don't know what these other ones are here, log base plus 1. Okay, so these are just shorthands for other ways of computing the logarithms for convenience. There's the mod, which is basically the way of breaking a fractional number into its whole part and its fractional part, raising something to a power, taking the square root. All of these things should be pretty familiar to you. Now, things that won't necessarily be familiar to you are these guys here, and these are some discrete math kinds of functions. These are the ceiling and the floor functions, like I was talking about before. The one that we use, that floor f, that I was using to sort of like move things to the next lower whole number on a number line. Those functions are discrete math functions to some degree and are not the kinds of things that you often talk about in high school math. Now, maybe some good high schools in good high school math talk about them, but certainly I don't think mine did. So these are some that you may not be familiar with.
I can't even remember. I mean, at one point when doing basic arithmetic in 1 through 6th grade, right, you would learn about rounding fractions and learn about floor and ceil conceptually just with arithmetic. But yeah, it is interesting how often these things come up in programming, though. At least this kind of programming. I almost never touch this kind of math logic in my day-to-day work. It's all, well, sometimes I do. It's just very rare now. Very, very rare. Usually it's just I'm taking some data that somebody's inputting into a browser, tossing into a database, relating it to something else. It's not all that fancy as far as the math goes. But sometimes, like, I wrote kind of an analytics processing component to this Elixir application I've been working on for a long time. And it takes a lot of data and then just averages it out. But that's not, it's just an average, right? There's nothing super interesting about that. It's getting at the data and knowing what data to average. That's the hard part.
But a lot of them are very straightforward. Like I said, ceiling and floor are two that we were interested in and we talked about on the previous streams. But basically, those are all sort of implemented in there as well. Now, the interesting thing about this math.h this math.h file, is these are all functions that would actually be implemented actually in the C runtime library calling a function. So for example, if we actually step in here, I guess I already had it running. If I actually step in here to, oh, is that function not getting called at all? That's odd. Don't you think that's a little odd? Why is that getting, how is that possible? What am I missing, folks? Did not, oh, just probably just didn't load the PDB, as always. We're gonna have to fix that. I have a plan for fixing that, by the way. We'll talk about that separate. MSVC, Visual Studio, always the perennial thorn in our side, unfortunately. All right, so basically this floor function, if we go ahead and right-click and go to disassembly, right, we can see what it's actually doing here. It's going to go ahead and it's going to actually call this floor f function, right, which is in the C runtime library, and I don't actually know if I have that in.
God, it would be so cool to just debug alongside him and go into my own debugger and my own environment and just see the assembly, you know, that is being called when these Odin math procs get executed. I gotta make it happen at some point. I've mentioned it like 3 or 4 times in a row here on stream, and I have to do it at some point. So I should really just shut up about it and then pick a day to go and do it, try and make it happen.
It doesn't look like this is installed on the machine. You can't seem to find it. So I'm not exactly sure if we've even got it on here. But point being, this is actually the C runtimes function in here that does the floor. And you can see that it does a bunch of stuff, right? It's doing things, and so on, right? And that's to do this floor function, which, you know, is pretty expensive when we look at all this stuff. It's doing tons and tons and tons and tons of stuff. And then it gets out here to actually get the results. So that's just a lot of work for this floor function. And remember, the only thing that we needed this floor function to do, the only thing that we wanted to do, was basically produce the next lower whole number on the number line, right? The only thing that we actually wanted it to do on here, right, was if we were looking at the number line like this, right? All we wanted to do, we wanted that floor function to just drop us down to the next one, right? That's all we wanted it to do. And so what's kind of curious about this is it'd be interesting to know, right, is there some way that we can go ahead and do that in a more efficient way that's just like simpler and doesn't involve using the C runtime library and you know, who knows what it's doing in there, right? Doing a bunch of stuff to comply with the C standard, essentially, but we don't actually know if we need to comply with the C standard because there may be ways that we can do stuff entirely without that, right? And so one of the things that I kind of want to point out here is, actually I don't know if I need to open the Intel architecture reference panel just yet. One of the things I want to point out here is that the Intel chips nowadays, anything that's going to be in a machine that we are going to be shipping on is going to have SSE2, right? That's basically an instruction set that, you know, for those of you who don't know, basically the processors on the Intel processors that are in all of the machines, like the one that I'm working on now, or anything that runs Windows pretty much, and anything that runs Mac OS X, and actually, I guess for that matter, the things that are in the PlayStation 4 and the Xbox One, for example, they are all running Intel-based architectures, and those Intel architectures get revised over time to have new instruction sets in them. So the instruction set that we're on right now is called x64, and x64 is basically a 64-bit version of the old x86 instruction set. It was made, I believe, by AMD, and that's why it's sometimes called AMD 64. And basically, it's just the basic set of instructions that we use to run code. That is what our code gets compiled down to. It's what, when we actually run this stuff, and I drop in here, and I go to disassembly, these are x64 instructions. That's what they are, right? So like move SS and call and CVT and blah, 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 blah. Those are all x64 instructions, but not every processor has the same set of x64 instructions because as the processors get revised over time, they add new instructions, right? And so they come up with names for these, like there's SSE, which is one set of instructions that all the chips will have nowadays. SSE2, right? There's even SSE 4. There's AVX. So they keep adding newer and newer instructions, which basically add to the set of instructions that you can call, and oftentimes also add registers. So they add more registers to the processor that you can access, right? And so basically any CPU that we're going to target is going to have SSE2. Like pretty much everything that we could possibly hope to run on is going to have SSE2 at least. I don't remember exactly when it was introduced, but it's been around a long, long time. And so really, all of the SSE2 instructions, I don't know if we've got a good list of them here. I want to get a better list of these. Let me take a look. SSE2, MSDN. There we go. So if you take a look here at these at MSDN, if you search for MSDN and SSE and SSE2, they've got a little overview here where you can kind of pop down by various types of instructions. SSE MMX was another one, a very old one, by the way, of instruction addition. That was on x86 as well. So these are the different instruction sets and sort of the instructions that we have available. And for SSE2, if I remember correctly, there's a bunch of instructions that actually allow you to do things. There's a number of things that you are able to do with these instructions that will probably let us just go ahead and do our own floor in a much simpler way. Now, like I said, I promised I would do everything from scratch on the stream, so that includes me having to dig through documentations because I never remember what the intrinsics are for stuff. I don't do SIMD programming often enough. I always have to go look them up. Whereas if you're a super SIMD, if you do SIMD every day, you just kind of know what they all are. So SSE instructions I always have to look up. But basically, this is where I typically go first, right? I go to the MSDN page because I've got them kind of listed by what type of instruction they are. It's a little janky. I don't love these docs, but I don't know of a better set of docs where they're listed by type, unfortunately. Sometimes I look at the Intel Architecture Reference Manual, which also has some sections like that, but yeah, it's a little ugly, it's true. But anyway, if you go in here, you can click on things that talk about sort of what kinds of operations there are, and you can see, like, I'm going to click on arithmetic operations, right? And I'm going to make this a little bigger so we can actually see it in its entirety. So you can kind of see what all the instructions are that the processor has. It's got, add, subtract, multiply, square root, reciprocal square root, min, max, right? So it's got all these sorts of things. And so if you know that you have these, then obviously you can write things that use them. So the question is there anything in here that we could use essentially to floor, to floor our number? And the thing that I can't quite remember is whether or not, I don't remember if you have to go to SSE4 first, which I don't know if we want to necessarily be using. If you have to go to SSE4 before you can reliably do a floor in one instruction or not. I think maybe you have to or not. I'm not entirely certain. Anyway, point being, what we want to do is we want to look up in here how we would do, say, the floor instruction by using these intrinsics, and if we, and similarly, like, figure out how we would do sign and the other sorts of things we need to do using these intrinsics. And then what we'd want to do is we want to come back in here, and instead of using math.h, what we'd want to do is sort of introduce our own math.h, if that makes sense. We'd want to introduce our own sort of utility layer that for every platform that we care about, which is basically, it's basically just going to be ARM Neon, which is the instruction set for like mobile devices, and SSE2 for the most part, or maybe if we decide to do something higher than that, SSE4 or something like that, some version of x64. We'll basically make a thing that for each of the operations that we care about, like floor and like sign, we will go ahead and make our own implementation where we know what it does, and we know that it does only as much as we need it to do, right? And that it uses the most efficient processor operations to do that. And so that is where I would like to get to on that. I don't know that we want to necessarily do that right now, but that is what we have to sort of drive towards. So that's one thing to think about. And by the way, I should also point out that sometimes, and I don't actually know...
I will not do any of that. I'm just going to use Odin's math package because as fun as I'm sure it would be, it's taking me too far away from the, like, how do you actually focus on the game part of it? Yeah.
If we can make this happen. Sometimes you can also get the compiler to...
And like however I call those intrinsics, whatever I do, to essentially redo the work that the people working on Odin have already done. Whatever I do, it's just going to be inferior. I know it in my heart. Rapunzel, Rapunzel, let down thy hair looking... Ah... I mentioned it when I went live, but I had to take a shower right before the stream today. It was just an insane day. It's been an insane week. It's been an insane last couple of months, to tell you the truth. But I'm hoping things will calm down soon, and I can stream when I want to stream, which means not, showering right before a stream. But I could smell myself, and that's never a good sign when you can smell your own body odor. So I had to clean up. And I don't want to tie up my hair when it's all wet like this because it doesn't feel good. So there you go.
Do some of this work for you if you don't want to do all the stuff that I just said. If you basically turn on optimizations. So, for example, we are doing something where we have all of our optimizations turned off. We have -OD on our build line. So basically, we've turned off optimizations entirely. There's no optimizations that are allowed to happen. And so one thing that we could do is if we turn on optimizations, right? If I say -2, I think, I'm not sure I actually remember what the highest level is. We can double check. But if I turn that on, then it'll actually compile it with optimizations. And one of the things, so the first thing you notice is that I can't even set a breakpoint here because this function has almost certainly gotten inlined. So what I have to do is I have to actually go find where that floor real 32 and 32 actually happens. And I need to actually look there to see what the actual code does. So
interesting. So I wasn't going to talk about this, but he actually covered the inlining thing a little bit in the Q&A of day 30. And exactly what just happened right there, where he was trying to get into that breakpoint or get into the code in the debugger with that breakpoint. Because it's inlined and he just turned off optimizations, I guess, that wasn't working. And so this kind of plays into the whole idea that unless you really understand what you're doing, avoid inlining, I guess. At least with C, or at least if you're not willing to pay that price of like, hey, you might have to do the debugging. You might have to go about debugging things a little bit differently. But do so at your own risk if you're going to inline functions. But don't have that concern in Odin, right? Because I can't even tell the compiler, hey, inline this function. But the equivalent to, I think, maybe this isn't actually equivalent to my layman brain, it seems like it should be equivalent. So he turned off like the debug optimization flag. He replaced that with like a faster optimization level, that O2. And for Odin, it would just be, I think, maybe my head was blocking that. I think it would just be getting rid of this debug flag, which would then, you know, optimize things. The compiler would optimize things to run faster, ideally, right? So if I do the same thing in my build game batch file, you know, that way both when I'm building the game separately from the main program that runs the game, neither one is using the debug flag. But then I have to keep in mind that just because of the way I've done this, when I go, I don't think I have any Odin debug references in here, but I do in the main package. Now my Odin debug stuff won't fire because we're no longer compiling with the debug flag, which means that I'm not going to be printing out my lovely, or am I? Did I do something? Did I not save that properly? If I go into build, not bad. Did I not save this? Yeah, there we go. So now I'm not printing out my frames per second or any of that other stuff. So, but I can kind of work around that. Whoops. And kind of work around that if I just kind of, like if I go down to FPS, wherever I'm printing that out, I can just work around that by saying or true. So it'll run in the compiler will compile things to run at a faster pace. It'll turn on optimizations, right? And because we're getting rid of the debug flag. But because I'm just saying true here, it'll still print out my FPS stuff. So that's kind of how I've been doing it to work around that fact. If I still want to print out some debug information with compiler optimizations, or I guess the compiler debug flag turned off, it's just kind of inverted, right? Instead of turning debug off, how am I trying to say? What am I trying to say right now? Instead of turning debug on, I'm just not turning it on because you need to pass that flag to it. Whereas with the, I think he's using Clang, right? When he's passing that OD compiler flag in, he's turning debug on, but then he has to specify something, I guess. He has to specify some optimization flag to the compiler, so that's why he has to put in O2, but I don't have to do that. Like, I can just take the debug flag off. So I don't know if those two things are actually equivalent, you know, across from Odin to C. I'd probably have to go and verify that for myself before I can start saying that's actually the case or not. Hey there, Dode. Let's carry on. Actually, I saw that I got a text here a minute ago. Okay, sweet. Chelsea is on her way home with one of our kids who is growing nice and big. He's grown in his first 3 months of life, 3.5 months, I guess. He's grown about 6 inches longer. His head is 85th percentile, just about. I think it was 90th at his last appointment, or 95th last time. So he's starting to even out. He's getting longer, and his head is getting more proportional, so I'm happy for him. Yeah, let's go ahead and jump back into the code here.
Going into the disassembly, and see if it does anything smarter. No, it still does floor, and there's nothing useful we can do about that. Sometimes you can set optimization levels where it says, don't worry about floating point consistency and stuff like this. I don't know. I'm not sure if there's a way to do it. Let's just double check to see if there's a way. MSVC, because I want to just point this out for people if they can. Someone on the stream will probably know. Fast floor F. I just want to know if there's any way to tell it to do a better version of that. Why did it link me here? I'm not.
Congrats on your large child. Thanks. I mean, he's not large. He's growing substantially, which is good. But he's like right in the middle, depending on which metric you're looking at. His head is enormous, but the rest of him is just right, you know, in that slot between 20 and 80, I guess. Well, I don't really know. Yeah, because that's the way percentiles work. No, is it? I don't know. I'm not going to start talking about math shit that I am really out of practice on. But anyway, the point is he's getting bigger and he's doing exactly what he should. He's doing everything that a 3-month-old should. Congrats on his gains, yeah. Yeah, both of our kids have enormous heads like me. My head is so big, I have to wear all of my hats on, like, all of my snapbacks on, like, the last button. Right? I mean, part of it is the hair, right? Because I have to, like, funnel my hair through the snapback. But even if I didn't have all this hair, the circumference is unreal. Hats are a problem. In fact, I try not to even wear hats at this point because it's such a pain with my hair.
Sure. Yeah. 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 Well, I don't know. We'll take a look. If someone on the stream knows, we can talk about it in the QFA, in the Q&A. But basically, like sometimes for certain intrinsics, there are compiler switches you can pass, or ways that you can tell it that you want to use that function. Like sometimes there's like a way to do like a built-in floor f. You'd call like a separate function, and it would know that it could do something that wasn't quite as direct or quite as comprehensive. For example, yeah. So okay. So this is perfect. This is what I was looking at here. Floor has an implementation that uses streaming SIMD extensions too, which is what we were talking about, right? For information restrictions about using the SSC2 implementation, set SSC2 enable, right? Okay, so basically enables or disables the use of streaming extensions in the CRT math routines. Of course, we want to actually do this inlined. If you use OI generate intrinsic function compiler option to compile the project, it may appear that it has no effect. The authority user trace to replace CRT calls. That's good. That's what we wanted. So let's go ahead and try doing that /OI as well, just to see whether we can get it. I just want to see if I can show you this. I apologize if it takes a while, but I really kind of wanted people to see the compiler doing two different things here because there usually is a way to make it do it. No.
This whole first half of this day is motivating me to go and dig into all those different compiler options that Odin gives, because there's no build system with Odin. There's just, you can Odin build and then pass, or Odin run and pass all of these different compiler flags, and it's really neat. It really lines up with Casey's approach quite nicely, and so that's why it's one of many reasons why I've been pretty happy using Odin. Big hair sucks for hat wearing. I don't really wear hats, but when my hair was longer, beanies just sat on top of my head. Yeah, it's just one of those things where it's like, if I want to have long hair and really more to the point, not have to deal with getting haircuts all the time, then I need to accept that hats aren't going to work out too well. It's tough. It's a tough life, but I find that it's worth it.
Why are you still doing that? Well, I don't know how to make the compiler suddenly do it. Anyway, point being, sometimes, maybe I could try calling something else, I suppose. I don't know. Sometimes you can get the compiler to do smart things where you could basically say, hey, look, I know that maybe it's not completely compliant with the C spec or something, but I would like you to go ahead and do it. Maybe I have to enable SSE2, but we're in x64 mode, so it knows that. I don't know. I do not know. Anyway, we'll have to ignore that for now, but please, if someone on the stream happens to know how to get the compiler to do some clever stuff, please mention it in the Q&A so I can show it. Basically, sometimes you can convince the compiler to start doing some of that stuff for you. I tend to not rely on that too much, only because, like you just saw, I never remember compiler switches, or even if I do, I don't necessarily know that the compiler can be trusted to do them and so on. So I tend to just like to take that out of the equation and actually have my own file where those will actually be called. So, essentially, what I want to do is start to think about these things like floor wheel 32 and round wheel 32, these sorts of things. What I want to do is I want these functions to eventually kind of migrate out into a math file where we can make the platform-specific versions that will do the right thing. And so I'm not sure exactly what I want to call that. Maybe I'll call that handmade intrinsics.h, for example, and we will just move those into there for now. And really what we want to be able to do here is we want to be able to do more efficient stuff using whatever's available on the platform for each of these particular instructions. So
if I wanted to be really pedantic about this, I could start like defining my own floors and rounds and truncates in, a separate math file. But it just seems pointless because, the calling the functions or calling the procs right out of the package just seems fine. I know I did something similar when I was working through this in Zig, but I think once I got to some of the intrinsics, I had to call them with inline assembly or whatever. But I think because of Odin's intrinsics package, I don't have to even do that much. So it just seems like it'll ultimately be pointless, but maybe there will be like at least one call or two that I need to think about kind of isolating into an intrinsics, not package, but a different file where I can kind of isolate those out and know where to look for those sorts of things if I need them. But for now, I think we're okay.
That's something that we have to deal with, and we're going to have to deal with.
Just write your own compiler, Casey. I wonder if he's ever tried. I know Well, I think he mentions it a few times over the course of the series that he's not like a super hardcore compiler guy, right? But it's definitely something that I might explore at some point if I just decide, you know what, I need a break from games programming. I don't know when or if that day will ever come, to tell you the truth, because there's so many different things about games programming that you can go and pursue, so many different niches that you could choose to carve out and really get very educated about. But you never know. I might just get a curiosity. Like I've got this curiosity now about all the different kind of optimization options there might be for Odin's compiler. It's just getting me to think about some different things outside of just the code that we're writing here.
In a number of places. We're going to have to deal with it because we're going to need a sine function as well. We're going to need a cosine function, right? We're going to need a bunch of these things that you'll see over time. We're going to need an atan2. Tan2 is usually y over x, isn't it, though? Sorry, just want to... sorry to talk out loud here. Sometimes I get in the middle of something and I'm like, wait a minute. Atan2 is usually not the way that I just typed it in, but you know how it is. Hello? It's usually written y.
Why can't I spell atan? See, it's all right here.
Anyway, so point being...
Uh-oh. Well, I just spotted these to-dos here. I didn't see that before, but Ginger Bill has left himself some notes to get good, so to speak. He wants to write better atan procs in here. He wants to make them faster, and he wants to make them better. Well, maybe that's something that I can help at some point with, but for now, I imagine I would just get in the way. So I'm just going to stay away from that. I'm sure it's fast enough for any of the purposes that I'll have on this stream.
If you look at what the sort of stuff that we're going to have to do here is, we're probably going to have to spend a fair bit of time going through here and talking about how this stuff works at a lower level and implementing them based on each particular processor and so on. But for now, what we're essentially going to do is we're going to say, and you know what, and I can eliminate these to-dos for now by basically making just a giant to-do which says convert all of these to platform-efficient versions and remove math.h. So basically, what we're going to want to do is kind of come through here and do all of those that way. But that's going to take us a little bit of time because we're going to have to go through and look at how to implement things like sine because processors don't always have sine and you have to implement it yourself and so on. So for now, we're just going to call these guys here. But essentially what I want to do is make sure that our code isn't littered with calls to math.h. I want it to be calling into here so that we kind of can see all the stuff that we're using and off we go. All right.
Like worst case scenario, I have to come in and update these proc calls that I have to Odin's math package for, whatever reason, the signature changes or the name changes. If that happens, so be it. I think I can live with that just fine. That's the only real consequence to not implementing this part myself.
So the reason that I bring that up now is because of floor f, certainly, which we want to get rid of. But also there's another reason, atan2 f, y, x, there we go. There's another reason I bring it up, which is that I wanted to start talking about trig and vectors because there's a bunch of things that we actually do need to talk about as well related to other stuff with our tilemap. Handmade intrinsics.h, there we go. Okay, so... we need to do those math functions. But the other thing that I wanted to point out is, well, okay, there's a bunch of stuff that we're going to have to start talking about, like vectors and these sorts of things. And I got to introduce those concepts sort of over time. And that time is probably going to be pretty soon. If it's not this week, that's probably going to be next week. What I want to introduce, though, just right off the bat, is when we're thinking about this tile map, there's a bunch of things that we want to do to it, but one of them is one that may not be sort of clear to anyone if they haven't actually gone through this process before themselves. And so rather than get all the way to the end of it and then show you that it's kind of unfortunate and have to sort of switch it all around and do it again, I'm going to kind of jump to a part in the implementation and show you what will happen so that you can kind of understand one reason why we need to think about it and so on.
I do really, really hope that we get to vectors sooner rather than later. Like I'm dying to use some of that array programming that Odin has because it just seems like such a killer feature. Potentially specifically for this domain and really anything having to do with mathematics, but because graphics is so mathematics heavy, it's really a tailor-made feature for the kinds of work that we'll be doing a lot of on stream. It's just really, really compelling.
Yeah, basically, as much as possible, I will discover things on the stream for you in the natural way that they would get discovered. But sometimes I kind of have to head things off at the pass to prevent us from doing like a whole engine the wrong way and then coming back to it later and going, well, see, that's why you wouldn't do it this way.
Yeah, it's such a delicate balance to strike, right? Like, how far do you go in the wrong way to prove that it doesn't work that way before going, okay, now this is how we can address all of the failures by doing things that other way?
Sometimes I have to use experience and kind of talk about it earlier than it would normally come up. And so this is one of those cases. What I want to talk about now is I want to talk about basically the coordinate system that things are in. Now, what we've been doing so far when we made this tile map, right? When we made this actual tile map, I sort of showed you how to come at it from first principles, and we did a reasonable job of that. We've got it working right now. We can watch multiple tile maps. It's fairly clean on the inside. There's nothing particularly odd going on. There's some stuff I said I wanted to kind of continue to push on, but for the moment, it's looking okay. But we've baked into here a very specific assumption. And one of those assumptions is that we're just dealing with pixels on the screen, right? Because basically everything that we did, you know, our tiles have a known pixel size. When we move things around, we're moving them in pixels and this sort of thing. What that means is if we were to change the resolution, right, of our screen, we would have to rewrite all of that code, essentially, right? I mean, let's say, for example, I mean, just for the sake of argument, because we could do this actually pretty easily here, and I'll show you what I mean. Let's say, for example, we came in here, and we wanted to change the size of the tile map. So we were going to change it from being 60 pixels across to being 30 pixels across, let's say, right? We just decided to change it. And so here we go. Oh, of course, my guy's already stuck in the geometry there. I'm going to have to move him a little bit over from where he is because he started off in the middle of the world. Hazards, ladies and gentlemen. Excuse me. So essentially, this is, you know, an example of what would happen if I go ahead and change that value so that now the tiles are not as large as they used to be. Instead of being 60, right, they're now 30. But, oh, and you'll notice the offset is wrong as well, right? Because the offset is one entire tile to that direction. So
Damn it. Thanks, Devil. I don't know why, just like this point in the day, I really need to stop letting myself stream this late in the day because my brain just can't connect one series of events to the other well enough. What I was talking about was the upper left X and Y stuff there, where I was trying to remember why we did that at a glance yesterday when I was making some changes. Where was that? Down here. I was looking at that and I was like, why does the world have this stuff? What is this even for? And it just had to do with the way that we were presenting the tile map in the buffer. This negative 30 offsets it to the left a little bit so that it presents correctly in there. And then what did he do? I think he just changed that to 30. Or maybe he changed, yeah. So this stretched it all out. But we have to change both of these to 30 to get that smaller tile map. And then of course, like he just showed, what was it, player tile or something, or just player X maybe. Yeah, player X, bump that up to not 751, that's wrong, 175. And there we go. Of course I'm moving all fast because I bumped up the delta there, but yeah.
So we should actually probably set these relative to the tile width, right? We should probably set them that way. Anyway, so here's our map again, right? And it looks roughly the same with a, anyway, relative to the tile width, right? We should probably set them that way.
Okay, so all he did, right, was change this value here to be based off of the tile width, right? It was like negative tile. What did we define tile? No, tile width is right here. Where did he make that change? He made the tile height based off the tile width. Is that right?
These relative to the tile width, right? We should probably set them that way.
Oh, no. Okay. I see. Okay, so the problem is, right, that I'm... I get it now. Because we define the world here, we're saying that these right here need to be based off the tile width and the height. But we don't have a world, we don't have a dimension, we don't have, that member value is being assigned in the same, you know, expression here. So I have to figure out, do I want to predefine these, the tile width and height? And then assign them in here, and then calculate this I forgot to mute my phone. Whoops. And then calculate this in that expression, or do I just want to define my world and then assign these off of the world? I guess I'll just do that. First time I'm actually, oh my gosh, making any changes during the stream, so I'm just like, how do I code again? How does my editor work? And then this is going to be off of the world's tile width. And I think, what do you do? Divided it by 2, and then we're going to the left to offset it, so that looks right. Yep. Jeez. Such a small change.
Anyway, so here's our map
so much
again, right?
effort.
And it looks roughly the same with a with a smaller thing. But what you'll notice is the guy now moves twice as fast, right, relative to the size of the of the stuff, right? Because his speed is in pixels. So if we change the resolution of the tiles, just the resolution of the imagery, right, it's as if the whole world has gotten smaller. Because everything that we're doing is effectively in some units, and those units are pixels, right? Now that's a perfectly normal thing to do, and like I showed you, it's what you would do if you move up each step and sort of as you go condense things down. Now the problem is you will never figure out that this is going to break something unless you try to run your game at multiple resolutions. And it's entirely possible that we would not really be trying to do that for quite some time. And so like I said, what I'm doing today is, or what I'm doing right now essentially, is kind of forcing that issue and pointing out to you like, okay, let's start to think about the ability to change resolutions way easier than it may ever naturally come up or naturally occur to you. Because that's a very real problem, and we don't want to bake that assumption into our game, or we could create all kinds of headaches for ourselves by assuming that our units are pixels, when pixels are just something that we use to display on the screen and don't really have any meaning in the game world necessarily. We should be able to double the resolution or have the resolution of our tiles in terms of graphics without the game changing at all, right? The game itself should play exactly the way that it plays. And so that's the first thing we need to think about, is the concept that units, there's such a thing as the units of our game, and those units may not be pixels and probably shouldn't be pixels. Okay, so that's one thing to think about. So that's thing one. And thing two that we need to think about is how our coordinates. So I'm basically trying to set us up to talk about the sort of the coordinate system of our game here. The other thing that we need to sort of think about here is, well, we know that pixels are one unit that we could be in, and there's reasons why we probably wouldn't do that. So that's one thing. But also, what direction do things go, right? If you think about it, this guy here, when he moves left to right, he's moving positive. We add numbers to him to move this way, right? So essentially, if you wanted to draw what our coordinate system looked like, right, you would say that x, the x-axis, it gets positive in that direction, right, on the screen. But what happens with y, right? Now I don't know if you remember, but if we go down here and we take a look at what happens when the player presses the up button, right? If move up is down, then it's actually a subtraction that we do from the guy's y position. So really, when we're going upwards, we're subtracting. We're going downwards, we're adding, right? And so if you think about it, that means that y, if this is the y-axis, y is positive that way and negative this way, right? So if this is the origin of our coordinate system, right? That's what it would look like.
Man, that was a big one.
So, again, there's an issue here. The issue may not be obvious, but it's one that I would like to demonstrate earlier rather than later, and that is that this is backwards from how all math is done, right? We are essentially doing something that is written in a coordinate system where it looks like this, and this is positive x, and this is positive y, but every math textbook that's ever been written in the history of time that I'm aware of anyway does have x positive going that way, but y positive goes up. Right? This is how math looks, always, pretty much universally. And so if you're someone who's used to working with math, which you will be if you ever took high school math or anything like that, you will expect y to be going up, and all of the stuff that you do when you look at math textbooks and physics and everything else will be drawn this way. So it's y goes up, and angles are measured sort of starting going counterclockwise. They do not go clockwise, which is what they would do on this, right? Circles are drawn this way, and so on. So really, we have another problem. We have our first problem is the pixels versus world units problem, right? But we have another problem, which is the upside down problem, which is the fact that our coordinate system currently is upside down from what math would want it to be. And there's no real reason in practice why you have to have your coordinate system agree with math's coordinate system. Okay, if you don't want to, you don't have to. There's no compelling reason. There's no objective truth to what direction y has to go, right? But I can simply say from experience that you will save yourself a lot of headaches if you are constantly looking at your math textbook and seeing this, and then you can go type something in, and it is that over in your game world as well. because otherwise you're constantly having to deal with this inversion that occurs between what you see in a math textbook when you're trying to do something or looking up something advanced math-wise and what you actually go ahead and do on the screen. For example, if we wanted to shoot a projectile at a particular angle, let's say, we've got a particular theta and we want to shoot a projectile off at that angle, right? We would know, and we'll be talking about this a lot more, so if you don't know, that's fine too. There's cosine and a sine of that angle will give us the x and y of the vector that we need to sort of shoot it off in that direction. Well, if you're thinking about it in this way and you're looking at your math textbook and trying to learn from it this way, and then you go and implement it, and your dude is always shooting the other way. It's like, oh, he's shooting down instead of up. What's going on? I'm totally confused, right? And then you're just like, oh, right, my coordinate system is backwards. And the more complex your equations get, the easier it is to forget in there somewhere that there's an upside downness and wonder why stuff isn't working and they're right subtly wrong.
There's something pretty interesting about what he's driving at here, and I don't even know if he really is consciously aware of the fact that he's driving at it, but he's saying, on the one hand, there's no objective truth. Like, if you want to treat y as being this thing that actually goes down on the plane of your screen, in the 2 dimensions that it has, then you can do that and you can technically make it work. But the fact that in books, y is always going to be treated as going up, and when you're trying to reconcile those 2 things at the math you're learning, y is treated as being up, and then when you go to draw the pixels to the screen, y is going down. The fact that those 2 things are not congruent is going to mess with your reality. It's going to make you feel a lot of pain, probably. And so it's like, well, if there is any objective truth, it's going to be your perception. And if what you're feeling is that incongruency with, like, oh, I'm learning out of the book, and the book says that y goes up this way, and then I'm going to do work on my computer and y is going down, it's just like, maybe there is not an objective truth, but there is certainly a subjective truth, but it's subjective, right? So interesting how that sort of thing works out.
So I would say that we have 2 problems that we probably want to fix. We want to fix the pixels versus world units, and we want to fix the upside down. And I wanted to just kind of introduce those now that we're sort of a little ways into it, because those are things that, just from experience, I can say we probably don't want to bake into our engine, because we're probably going to be sad if we do so, and there is no real obvious compelling reason why you have to do either of these 2 things. But just like I said, if you want to make your game support multiple resolutions and you want to have an easier time going from math textbooks to your game and vice versa, it's just they're good things to do. And so I'm going to do them in our code base for those 2 reasons. But your game would work just fine without them. If you didn't ever care about changing the resolution, or you want to do some hacks to change the resolution, and so on, and if you didn't ever care about going back and forth to math textbooks, then you would never have to worry about that. Okay, so where does that leave us? Where indeed? It leaves us with 15 minutes. I've been talking a lot tonight. There's been a lot of blabbing. I've been a blabbermouth, it's true.
It's almost a little bit disappointing that there is just not much code to write today, but at the same time, I'm a little bit grateful because my brain is mush.
But where does that leave us? It leaves us at the point where we kind of have to start to think about this tile map thing a little more robustly, like trying to just make this a little cleaner. Gotta do a little stretching today. I gotta go stretch. After the stream's over, we're stretching. It's gonna be stretching time. Maybe we could do one of those group calisthenic things where, like, I do the stretch and all of you guys do the stretch as well, and then it's like, group calisthenics. Yeah. Anyway. So
I already did my workout, Casey.
We gotta start thinking about all these things. We gotta start thinking about tile maps. So there's a couple of things that I still want to do that will naturally fall out of the things that we're doing, but those 2 that I introduced today are things that wouldn't, I don't think, have naturally fallen out. They would have been things that we would have to get to later and then realize were busted and then be upset, right? And so I'm just trying to kind of save us that sort of grief by pointing them out ahead of time because I've been there already and know that these things go poorly. So now that we've got that out of the way, what I would like to propose, first of all, is having some notion, just to start off with, having some notion, therefore, of what the units are in the world. Right? I'd like to have some notion, I'd like to be able to tie this back, basically, to an actual notion of how big things are in the real world. And the reason I want to use real world units, essentially, is because I feel like if I use real world units, it's easier for me to conceptualize how big things should be, and I can play with that if I want to. But, like, for example, if we want to implement something that has gravity, we know how fast gravity is in the real world. So if we already have real world units everywhere for stuff, then it's easier to just type in the value for gravity and be starting at something that's realistic, and then you can tune it from there, rather than having no idea what would be realistic and having to guess and then tuning from there, right? So given that, what I'm thinking about here is basically like, okay, so we know our guy, right? We know that our person is basically going to be about one, I'm looking at this, I'm imagining how big he's going to be. So I'm imagining that we want the player to be, something like that size, something like that rectangular size. I don't know exactly, but something like it. And so if we think about, I don't know how wide a human is across, right? But I mean, I feel like one of these tiles, for example, is probably not a full meter across. Maybe it's a meter across. I don't know. It's hard to say. But I would basically think that, if we were to ballpark the size of the guy, what we could say, here's what we could say. Here's one way I could ballpark sort of roughly what we might want those units to be. Let's say I open up Google here and I say, let's say our dude, he's a little kid. So I don't know. Let's say, what's the average height of, let's say, a 10-year-old? The average height of a 10-year-old boy was 55.2 inches. So let's just say, randomly, 55.2 inches times, excuse me, sorry, in meters. How big would that be? 52.2 inches in meters. So that's 1.4 meters, right? There you go, 1.4 meters. So how big am I? Let's just see. 6 feet in meters. I'm 1.8. So 1.4 would roughly be, sort of the height of one of the, one side of these, let's say, would be 1.4 meters, something like that. So if a tile on a side was 1.4 meters, we could actually use that value as sort of a calibration value to say roughly how big these things actually are supposed to be in real world units, right? We could come here and say our world definition, we actually have a thing which is going to be 1.4, right, which is meter, tile side in meters or something like this, right? And so when we create the world, we're just going to say that the tile side, one side of a tile measured in meters. I'm just going to say for now that that's about 1.4, right? It's 1.4 meters on the side of a tile. So if we wanted to measure now in the world how long something was, we could actually do it in real world, in meters or something like that. Now I'm not sure if that's exactly right. We're going to sort of say that that's roughly it for now. Okay. So what that essentially means is if a tile is that big in meters, right? And then we also have, right, over here, and I guess we could also say, I think let's go ahead and say definitively that our tile side is going to be square as well, because I know that I want square tiles. So let's go ahead and say a tile side in pixels, right, which we also have, which kind of forms this tile side in pixels. And I guess that should actually be a UN32, since we're not going to allow there to be a fractional pixels there. So tile side in pixels on the screen is going to be 60 for now. Now, you may want to let it be fractional. You might think, okay, why not let it be a fractional number of pixels on the screen for a particular tile? And the reason that I don't really want to do that is because if you think about it, we would like the art for the game to line up properly with the pixels on the screen. When we get to the renderer, you'll see why we may want to do that, to avoid basically having more blurriness introduced than necessary and more filtering introduced than necessary. So you may wonder why I'm actually doing this as an integer for now, but I think I want to do that for now. We'll see. If we could always decide later that we don't want to do that later on, but for now I think I'm going to stick with that. So basically the tile side in pixels is going to replace this width and height here, and this will now give us an idea of the real world size of things and how big they should be on the screen. And with those two, we can now do a mapping that will allow us to write things like the player position, right? We can write something.
Do I want to just go ahead and make those things constants? And then it becomes much easier, right? Well, not easier, but it just looks neater, because this looks weird. I feel like I'm creating my world. I guess I could just do it the way Casey's doing it instead of, doing this, declaring this world and all of its members in one expression. But he does this sort of thing so often that it kind of feels like maybe I should just do it the way he's doing it. I really don't know. It doesn't matter. It's up to me. I have the power. I'm in control. It's my code. I'll do it the way I want to do it. So I'm just going to go ahead and switch this, because there's just so many attributes, so many members here that we have. And this just looks better. I don't like having like some of the members defined inside of the instantiation and then some not. Gotta get rid of all these commas. And there we go. So there's no more tile width and height. We get rid of that. And then this right here becomes tile side in pixels, I think. I think that's what he's going to go with. And if there's no more tile width and height, then those will get ripped out there momentarily. Whoa, what have I done? Cannot convert untyped value to... Whoa. Oh, it's because, I see. I got rid of the type, I got rid of the F32 when I commented that out, so that's, yeah, that's better. And then this is just going to be tile side in pixels, I suppose. Well, he's probably going to change this, right? He's going to do some kind of conversion. So this is premature. I needed to write some code, so I just started jumping ahead.
Like the player position in a way that will actually tell us something more interesting than just how many pixels he's moved. We can say how many meters per second he's going, for example, or things like that, and then we can always map him back into where he should be in the world afterwards. Okay, so I'm gonna go ahead and fix the stuff here. I'm gonna change tile width to, because we got rid of that tile width to tile height, so we have to change tile width to tile side in pixels. Go ahead and change that everywhere that it was being used. And similarly, we have to change tile height to tile side in pixels as well. So
Okay, so he is just gonna go ahead and replace all of those. So wherever we have tile width and tile height, I'm just gonna go for broke here and do something a little bit dangerous. I'm going to replace everywhere where I see a tile width with a tile side in pixels. And then I want to do the same thing for height. And then I have to go back here and just get rid of that. Nice.
Okay. Let's see here. What did I do incorrectly? Unary minus applied to unsigned type. Oh, oops, sorry. I can certainly make that a signed type. No need to be overzealous there. We're going to choose a version from int to real 32. Is the upper left x is a real, so I will go ahead and make that a real as well. And it looks like...
Did he make tile side in pixels an int? I mean, I think he might have mentioned something about that, and maybe I just wasn't paying attention. Yeah, he did. So we're gonna have some casting going on here. And actually this should just go right here, I guess, and then just get rid of that. Keep the ints and the floats grouped together. So this probably isn't going to work. Yeah, we're going to have some casting to do like he was just doing. If I can go to where I meant to go, we can start working on that. So upper left X, this here now needs to be cast to a float, I believe, because player X is a float. Is it not? Oh man, once again, I can't go to definition of my game state for some reason. Yeah, player X and Y are floats, so we cast those. Was that it? No. Surely that could not be it. Come over here, and same thing. This operation is going to take place first anyways, so I can just, well... Yeah, no, because those are both going to be ints. Right? So I'm not losing anything by just doing the cast after the multiply. And then over here... Same thing. And we might actually be done. We are not done. Not even close, apparently. Oh yeah, and then this is this is what he was just doing. I don't know. Did he do that cast? Did he wrap the whole thing? No. Just around tile side and pixels, and then over here. I was thinking of getting creative with my editor commands, but I decided, nope, you'll just stumble over yourself and look like a fool. Just make the change. Same thing over here. We can just throw all of that into a cast because the multiply happens first. It's tempting to create like an F tile side in pixels, so I don't have to do this cast everywhere. Maybe he does something like that. Now we got so many F32 casts. And we are back to working order.
And make that a real as well. And it looks like that is... Yes, there we go. Okay. All right, so I think that's basically everything, and it looks like everything is still working properly.
I think it's just, he doesn't have to do it, right? Because the C compiler, or C++ compiler, I guess, Clang, because can Clang compile both C and C++? Man, I'm just so ignorant. It'll just implicitly convert all those ints into F32s because it knows, hey, you're trying to get, it infers that you're trying to get an F32 out of these operations. So that's why I have to go and do it manually in all these places where we're multiplying the ints out by other floats. But I don't know, is it worth it to take that out into a world F tile side in pixels? It might have just made more sense to leave it as a float, but I'm always afraid to do anything even the slightest bit different from how he's doing it and then suffer the consequences later on.
Really there, no oddities. Everything still seems.
I guess I should have made sure that I can still scroll on to the next tile map. Yep. We can go in a nice big circle to our empty rooms and back to the beginning again. Cool.
Correct. So that's fine. And now what I want to do is go ahead and start to make, well, I don't know if I'll quite start this yet. Maybe we'll do it tomorrow. But what I want to do is continue down the road of kind of cleaning up this tilemap stuff. Now that we have a notion of what those two things are, I don't quite necessarily want to use them yet because there's something that I think maybe we'll do one step of the tilemap compression first that we haven't quite finished yet, and then we will come back to it. So I think I've got time to do this in 7 minutes left. Well, actually, we started 5 minutes late, so technically we've got about 12 minutes left. So we're going to do these, and I'll actually put it to do here. To do begin using tile side in meters. Okay. So what I'd like to do here is basically say, looking at these two things and thinking about them a bit, I think I mentioned on the previous stream, because we were right in the middle of working with them, I mentioned that I didn't really love, and I have this to do here, these are still in pixels. This kind of was the foreshadowing of the thing that we were kind of introduced here. So I know that these things I kind of don't want to be in pixels anymore for canonical.
He's probably about to change that, right? Or maybe he's going to change that on a different day, but I did not catch this to do here. Slanty face. Tragic. Wow. How could we do this?
Positions. I already kind of said that. So I want to start moving to real world units for our offsets. But you notice we have these two numbers here. We've got the tile map X, the tile map Y, and the tile X and the tile Y, right? So what can we say about these values? I was saying before that, like, I've got this raw position. The raw position was basically a tile map X and Y, which is some index into which of the tile map portions we're having. Remember, just to give you a refresher, just for folks who, maybe forgot.
Let me swap over here so you can see his beautiful drawing. He does switch to a like dark mode virtual chalkboard or whatever, so we're not going to get these, blinded out whiteboard sessions. You'll be able to look at your screen and not have to just be in pain from how bright it is. Hello, Hatem you. Hatem? Hate MU? Yeah, you won't be flashbanged. Take a minute to compose yourself from this brightness.
From last stream, we've got, this is the setup that we've got here, right? We have a game board, a game board that currently looks like this, right? You saw me walking around it earlier on the stream, all right? There we go. So basically, you saw us walking around this, right? This is a tile map, this is a tile map, and so on. And we had made coordinates for these. We'd said like this was 0, 0, this was 1, 0, this was 0, 1, and this was 1, 1, right, for the tile map that we were on. And then inside there, we had additional things where each tile was numerated as well with a coordinate system, right? We kind of kept doing all these numberings. And so what I wanted to do is I wanted to say, because this is something that I saw as we were working on it, but we didn't have time to do it last time, what I want to do here is I want to say, why do we need two separate sets of indices, right? Why do I need the tile map X and Y and the tile X, tile Y, right? Since I know already, right, that we're going to have a fixed number per tile map there. And even if we weren't, let's put that aside for a second. Why can't I just have an integer for all the tiles in the world, right? Just, one integer for all the tiles in the world. So one integer for X, one integer for Y. And then whichever tile map you're in is basically just looking at that value and taking off, say, the high bits of it, right? It's just looking at whatever the high order part of it is, right? Does that make sense?
Not yet.
So, to map a tile X or a tile Y into a particular tile map, basically all we're doing is we're sort of saying, okay, let's go ahead and page. I mean, really what I'm saying is, let's make a virtual memory system for our tile maps. Let's just have a single 32-bit value for the X and a single 32-bit value for the Y that is the individual tile. And all the tiles in the world, so we have 4 billion by 4 billion is the maximum size we could support, which seems like a pretty reasonable size to support at maximum. Right, that's, what did we say our size was? 1.4 meters? So 1.4 meters times 4 billion, right, is that many meters. So that many meters I guess I'll copy that, circumference of the Earth in meters. So that's the circumference of the Earth. Well, actually, let's see here. Can I get that in kilometers? So figure 40 million meters if we were to walk all the way around the Earth. And this is how many meters we could support, which is more than that. So we can basically support an entire Earth's worth of geometry, which seems like plenty for our purposes. So if we do a 32-bit x and a 32-bit y, right? What I'm basically saying is, let's go ahead and imagine that 32 bits is broken up into, pieces of some kind, like chunks, basically, right? Where we basically...
Isn't there like a Marvel villain that eats planets? That's nothing for Galactus. See, it's all a matter of perspective. If you're Galactus, you can probably cruise that amount in half an hour or something.
Say, okay, let's say the bottom 4 bits, right? So that's 16 or something. The bottom 4 bits and the top 28 bits, or something like that, are going to be separated in these numbers. And the bottom 4 bits will tell us where in a chunk we are, right? And the top ones will tell us where in the tile map, where in the indices of the tile map we are. So this part tells us the tile map index, and this part will tell us which tile we are in a particular tile map, right? Basically what I'm doing is I'm packing the 2 numbers that we had before into one number and just segregating it by the bit amount, right? Now you're going to say, when you first see this, you're like, wait a minute, Casey, though, how is that going to work? Because if you remember what we did before when we were drawing a tile map, right, on the screen, we basically had tile map count x, tile map count y that said how big these tiles are. It was 17 by 9. And there's ain't no way you're going to get some number of bits down here to be 17. Right? They're either going to be 16 or 32, and there ain't going to be no 9 that's going to be either 8 or 16. So what gives, right? And that's a totally valid question to ask me. I'm very glad you did. How did I scroll like that? I don't know what happened there. I'm very glad you did. What I'm basically proposing is that we no longer think about the screen that is being displayed as the tile map. The tile map is just going to be a chunk that we can reference and store, but a screen will just be a view that could be viewing multiple tile maps at once, right? So for example, if our tile maps are 16 by 16, right, then basically we will have one tile map that covers essentially this much, of our displayed area, and then another one that covers that much or whatever. And when we look at a screen, we'll just reference 2 tile maps, right? No big deal. Very, very straightforward. So that's essentially what I would like to do, is make it so that we can go ahead and do that sort of packing, if that makes sense. So all right, if the
That's when you use a long. Yeah, it's weird because I don't know, like the way that my brain would default to doing this, the trying to accomplish the thing that he's describing, right, is I would never think to pack them. And I think that's the thing about this series that has started to transform my thinking. I'm only just beginning, but I can feel that I'm not thinking in terms of how the program, in terms of how you can define what the program thinks of the data as, like where you have just like an int, right? And then you have, maybe a slice and then an array, a string, whatever. Like I start to think more in terms of like, what are the actual bits and bytes that I'm dealing with here? And if I can start to really massage the manner in which I'm thinking about these things in that direction, I feel like you can become a bit more powerful in terms of the flexibility of your thinking of how to deal with data. Because I wouldn't think to start, shifting bits around to pack, 2 different pieces of information within the same member, right? Before I came across this guy in his stream, I'd be like, well, I would just have, my class, and then I put, the one thing in this member and the other thing in this, I would never have unlocked that, kind of approach without exposing myself to not just his stuff in particular, but a lower level kind of programming and just other kinds of programming in general than what I'd become used to.
If we've run out of time for today, this may be the time when I've done the least. No, I guess one other time I talked basically for the entire stream. I was going to say this may be the stream where we got the least actual programming done. But I was trying to explain to you what we were actually going to do. So okay, I'm just going to say that one more time so that tomorrow we can basically start directly on it. So what we want to do now that we've talked all about all of this stuff quite a bit is I want to basically take these values and I want to collapse them into one, right? So what I want to do tomorrow is I want to say, take the tile map x and y and the tile x and y and pack them into single 32-bit values for x and y, where there is some low bits for the tile index and the high bits are the tile page, right? And basically what we're doing here is we're constructing essentially a virtual memory system, exactly like the kind that you would see for just regular memory, only instead of it being a 1D thing like memory is, it's 2D. We're basically just making a 2D virtual memory system, right? All we're doing is we're saying we have some gigantic world, right, that's 4 billion by 4 billion across, right? and we want to break that up into chunks, right? And I'm thinking those chunks maybe will be 16 by 16, maybe they'll be 64 by 64, who knows? We'll talk about the reasons to make different sizes. But basically, we'll break those into chunks, and those chunks will be something like 16 by 16. And then whatever we want our game's display to be, however big we want it to be in tiles, we'll just grab out that portion of it and display that as the tile map. So instead of the screen and the storage being the same, we're just going to split those up into two.
I also think that what I was just saying a minute ago about, you're dealing with bits and bytes, like you're literally thinking of the data, the literal data, not the abstraction of the data. You're thinking of the literal data, the bits and bytes that you're contending with, that you're trying to manipulate to do a thing. And that's where you see a lot of people who seem to know what they're talking about, at least a hell of a lot more than I do, espousing data-oriented design or kind of data-driven development, I suppose some might call it. It's just a different lens through which you can apply the way that you're solving problems.
Pages. And again, you may ask, why don't I just store a giant 4 billion by 4 billion array for my tiles? Well, that would never...
And not just the way it's laid out, not just the way that you're storing it, but also the speed at which the CPU can operate on that data, so on and so forth.
That's too much. It's too large. 4 billion times 4 billion would never fit in memory, not even close. It would be absolutely massive. So what we're going to do instead is we're only going to, and we'll show how to do this later, as soon as we get this stuff working, we can actually go ahead and do the stuff for the storage. But basically what we're going to do is we're only going to store the places where the world actually exists. So as the world kind of snakes its way through various pieces, we're only going to store pages where there's actually data, and that way it'll be nice and sparse, and we won't have to store a 4 billion by 4 billion world, which of course you could never actually store. Okay, so I want to do that and turn it into a paging thing. So that's one, I think we'll be able to do that tomorrow.
Keep on forgetting that I can do multi-line comments with Odin. It just feels unnatural after not being able to do them for so long. So we take the tile map X and Y, and the tile X and Y, we're going to pack them into one member, one value, into two values for X and Y. Right. For X and Y, where there is some low bits for the tile index, and the high bits are the tile page. Yeah. Like, I would never think to collapse this stuff, right? And to just deal with those biddies. In that way. I'm just trying to think about the fact that, because basically the reason why he's going down this path, right, and the way he's describing it this way, creating a virtual, memory address for the entire tile map, is that we can't get that big of a world otherwise. At least, I suppose, not, without using, what would it be, like an I-128? Like, then I guess you could store those, but then not every architecture is going to have 128 bit sized integer. Does this even work? Is that a type? I guess it is. We're trying to do a bunch of assignments to it, so I don't know. Does Zig not have multi-line comments or something? No, it doesn't. Matter of fact, they only have single-line comments, and the reasoning for it is that it supposedly makes compilation faster, which I'm sure it does, but I don't know how much faster it can actually make it. Maybe, if you've got a massive code base with tons of multi-line comments, it actually makes a huge difference for compilation speed, but that's my understanding of it. That's what I've learned about it. So take that for what it's worth, but I did think that was kind of strange when I learned that. Like, how much better can it be? And I guess from the perspective of people who've maybe been dealing with C++ compilation times that are like an hour long, and you've got a massive code base, you know, with thousands and thousands of lines of code across hundreds or thousands of different files, maybe that actually adds up substantially. I don't know. I've never written a compiler before, so I would not know to what extent it actually matters. But anyway, so yeah, it's just there's something about what's going on here that I think I can kind of intuit why he's driving it in this direction, to use one or two members, right? One, I kept on saying one member, but it is one member for the X and it's one member for the Y, so that we're not having to have four members here. And then we can just treat, you know, the bits inside of that 32-bit integer accordingly to get at the address of the tile that we want and the tile map that or the tile chunk. You know, he starts using the phrase chunk because we're chunking into the tile. Like, you can think of the entire world that we're storing as one massive tile map, right? And then we're chunking it. So I can appreciate where that sort of change in the nomenclature is coming from, that he's going towards, but it's just something to really think carefully about for me, because I'm slow. I don't know.
I'll probably take the whole day tomorrow, but we can probably do that tomorrow. And then the next step, because of the things that I've talked about earlier today, is we got to fix these tile relative things. So we're going to compress those two guys down, but then these tile relative things, what I want these guys to be, right, is I want these guys to be, convert these to math-friendly, resolution-independent representations of world units relative to a tile, right? And so basically these are going to be, now they're going to be in those units that we talked about before, which is the tile side in pixels. So basically what we're going to do is we're going to convert these canonical positions over to something that's nice and clean. It can be used as a virtual index into a giant tile store that stores as much space as we want. For tile maps, we're going to be able to do a nice sort of math-friendly, resolution-independent movement of things relative to the tiles, so that'll all work nice. And then we can also get rid of this raw position, because again, we won't ever have to think again about things in terms of those pixels the way that we were. So we'll just store everything as the canonical positions, and we'll get rid of these. And that will make our tile map, that will start to get our tile map into really good shape, something that we can really start to think about being sort of a quality system that we're going to be able to use. And again, what we will do too down here, again, instead of this thing looping over a tile map, this thing will actually just loop over tiles and pull the tiles out of that sort of virtual store once we build it. So that is what we'll do tomorrow, but without taking up too much more time from the Q&A, I will close this, and I will say, let us go to the Q&A here. If you could, please prefix your questions with Q:.
So I think I have time for just a couple of questions of the Q&A here. My brain just won't let me read what I'm typing out at this point, and actually, like, this just looks wrong. Representation. Okay, yeah, maybe that spelling is correct. I have to read something 3 or 4 times and be like, does this even make sense? Are the words that I'm typing onto my screen right now completely incoherent? It feels like that sometimes. Yeah, it was probably for the best that this was a light coding day as far as the series goes. I'll make sure that there's nothing outrageous in there. I guess I'll just, I don't know, did he leave? I think he might have left those switches to increase the, or change the compiler optimization to 02 or whatever. He might have left those changes in there. I guess I don't really care if I leave those in. Yeah. Whatever. It's not like it's hard to change it back. But I'm going to leave that conditional change in there so that I can keep getting the FPS printout. Because I really want to know if I do something terribly wrong, which just tanks the FPS. I'll be able to see it, most likely, right? But if it starts getting just like all sort of out of whack, and then like sometimes it's staying up at 72 or whatever, and then other times it's dropping down to 30, I want to be able to see that it's hard enough to keep up and make sure I'm not doing anything completely wrong. The rest of this looks good. Yeah. Yeah, nothing too exciting. I guess we've made more changes than I thought, but it's really just all those casts from introducing that new member on the world. Okay, cool. Yeah, so I have time for, I think, a couple questions, but Oliver's waking up, so it's time to wrap it up here pretty soon. But normally he just kind of dozes for a little bit before deciding that he wants to party. So let's see if we get anything interesting here in the first few minutes of the Q&A.
And keep them to things that we've done today or on previous days, because if you want to ask questions about sort of off-topic stuff, you can always do that by coming to earlier in the stream, basically before the scheduled start time, like 8 p.m. If you come at like 7:45, I'm usually on the stream early and I field questions about whatever you want. But during the official Q&As, I like to keep it on topic as much as possible. Let's see. Will we be making a map editor? Not really, because this is a procedurally generated game. So you can't really have a map editor if you have to generate everything procedurally. Let's see.
I'm very interested in like the handcrafted aspect. I know I've said this before, but handcrafting like levels and environments, I just don't know to what extent I would be any good at that. But I think at some point that'll be like a little project that I undertake myself to try and see what making like a little level editor would look like, what that would take. I should also just get a list of all the things that I want to try and do and go off on my own that either Casey takes maybe hundreds of days to get to, or he just never gets to over the course of this series, right? So I think that's definitely something to think about here soon. I'll start getting a list together of to-dos for fun projects to tackle on the stream. There's getting a debugger, working with Odin, trying Remedy BG, which I can't remember who suggested that yesterday, the quote-unquote handmade debugger, and then the rad debugger. Start there, see if either of those are going to work. I should find out which one my buddy got working. I don't think it was either of those. I'm not sure, though. It might have been Remedy, actually, now that I think about it. He might have mentioned that to me. But, yeah. And then, so there's that, and then there's tackling a level editor, which actually turns out it's not super difficult to get something really trivial done. I did it when I was following, again, I'm going to plug his name again, Carl Zielinski's, one of his tutorials that he has for Odin and doing games programming with Raylib, and he makes like just a very simple level editor where you can actually like copy and paste this like little platform around while you're in the game, and it's pretty neat how easy it turned out to be. But obviously, to make it more sophisticated and sophisticated enough for like depending on what your use case is, it depends on the use case. So I'd have to think carefully before that. So I think the debugging project, getting a debugger working with Odin, so that I can use it on stream, would be the thing that I tackle first, and then doing the level editor, that's probably going to come a good deal later when I have a better idea of what kind of game I even want to try and make, because maybe I will just do something procedural, because that'll just wind up being the path of least resistance to do something, right? The goal is to do something and be very reasonable about the scale and the scope of that particular project, whatever it winds up looking like.
To fast floor, were you talking about I equals int fp if I greater than fp I minus minus? Well, so not really like, well, so let me show you, first of all, sort of, this is not necessarily what I'm thinking about for fast floor, but let me see if I can show you. There's a store instruction that I was thinking of in SSE4 as well that would be sort of the one-step way to do it. So, excuse me. Let's see. Oops, I wanted floor, not ceiling. So in SSE4, which I don't know if we should use or not, because I'm not sure how many machines have SSE4. I don't know what kind of coverage we get. But basically, there's this round PS function that actually can do all 4 different types of rounding. Let me see if it's got the documentation for that here. Kind of slow, kind of pokey. Flog them hamsters, flog them. All the hamsters on the Azure cloud right now. Run faster. Okay, there we go.
The Azure cloud. They have thrown so many more hamsters at the Azure cloud in the 10 years since he did this stream, and you know what? They're still running themselves to death to this day.
So if you take a look at this instruction that's in SSE4, this is when, if we had SSE4, I'd just use it. When I was saying about SSE2, I was thinking more like, okay, what are we going to cobble together to make it work relatively well in SSE2? But point being, because we could do like fraction extraction, or there's stuff we can do. Anyway, ignoring that for a second, this is like the Uber example of what I wanted. You can do an round PS, and that will basically take floating point values, and it will round them using whatever mode you want, right? And so you can do all sorts of nice rounding with that. You can do a floor, right? You can do a seal, you can do truncation, you can do rounding, and you can say whether you want it to go towards negative infinity or positive infinity, right? So you can construct the round that you actually wanted to be a floor, to be a ceiling, or to be whatever. So that's like the perfect instruction. That's the one you wish that they would have just had to begin with, but unfortunately never did. So what I wanted to know was basically, what is the shortest set of SSE2 instructions that I could do to emulate that for our purposes? Now, it turns out that actually we can do something a little bit more clever that I was going to get that will eliminate the need for floor in this particular case, and I'll add a thing here. We can actually just use truncate for our purposes, because once we have this stuff packed, we won't need negative offsets anymore. So it's a little anticlimactic either way, but we probably will need floor for other things as well. So point being, I'd like to go through and get a good feel for what's the easiest way to do an SSE2 into bucket thing. And I might have to ask some folks who are better at SSE stuff, because I forget it. I page it in when I do SSE, and then I page it out immediately, and I forget what they are. I'll have to study up. Recursive anomaly. Have you considered only storing the changes made and then just regenerating everything else from seed instead of storing it all? So that's an interesting. So what you're talking about is. So let me talk a little about that, because that's an interesting question. So what he's basically asking, or she, I suppose. I guess I don't know the gender of anyone. What the questioner is asking is, do we have to actually store everything, or can we generate stuff from seed values, right? And so when we go into a new page, when we go into a new part of the world, can we just generate it from seed and then recompress it? And I believe Minecraft works that way. And then just recompresses and stores the world that after you change it. It only stores blocks if you change them. I don't know. There's games that work that way. And there's two reasons why I don't like that solution. The first reason I don't like that solution is I feel like it generates worlds that are kind of boring. Like, worlds that can be generated per page by a seed look like they were generated per page by a seed. And so I am more interested in creating worlds that are a lot more creative than that, and involve things that would be much too expensive to create in a way that will allow you to create them from a seed on a page basis without an extraordinary amount of work. So I don't think I want it for that reason. But there's another reason I don't like that idea, and the reason that I don't like that idea is because I don't actually think that it's a good. It doesn't have performance leveling characteristics, which is to say that, let's say that you're like, oh, well, I can be more efficient by just not ever storing this, and then when someone comes in here and if the world gets modified in some way, then I'll write it back out only if that happens, right? The thing that I don't like very much about that is what optimization is that really doing? Assuming that the user does go through and do lots of changes to the world, then you end up back in the state that you would have been if you were just storing it, right? And so I'm not sure where the benefit comes. If it's just to sort of spread computation time out, then maybe that's something. But in general, it doesn't really save you any space if you assume the case where the user goes around doing as much stuff as they can to the world, right? So I don't see it being really that big of a win, or even a win at all, really. It's sort of something that only saves space in the case of a world that the user isn't touching a lot of, which again, isn't perhaps quite so interesting.
This is something that I was thinking about all day, dealing with all this Tilemap stuff the past few days, is that, when I see people ask questions in places about, like, how do I store a tile map that makes it easy to add new tiles at will and then, like, cull old tiles, I think it really makes sense if you're, like, let's take Minecraft, for example. You're updating the game world in place when you break a block, right? And then you're doing it again when you place a new block, and then you're building, make a whole building where there was just no space at all. So it's more like the whole entire world, it's all just one big matrix, and you're changing, if you're saying nothing is there, you're changing the properties of the thing, right? Like I'm trying really hard to articulate this correctly. Let's say you've got a tree in Minecraft, right? And you want to chop the thing down. And so you run over, you start punching it. You start a new Minecraft game. You start punching the tree. You punch at the bottom of the tree. And then I think the newest version of Minecraft, right? When you break the trunk of the tree, the whole thing just collapses into a pile of resources. That the grid, the space that the tree was occupying, in this case it's a 3D map, right? Tile map, but it's like a 3D grid where those blocks all existed. But what you're just like going this way, instead of like culling the blocks, like and saying that the blocks don't exist there anymore. You're just changing the properties of what's there, right? You're saying that not only is there no longer a tree here, but now instead it's just air, right? Like there's nothing there. There's no properties to the block, so the player can now walk through it because there's no tree to block them now. And so I'm just trying to think through that, and trying to understand. You would still have all of the world, the grid that makes up your blocks, right, would all be there. It's just you're changing properties rather than this idea of culling. So like when I see people ask that question of like culling, I'm like, I look at the way Casey is doing it, and he just says these are all the tiles in the world. Of course, it's 2D, but he had some of the properties in the world, is we'll see later on, are going to have like an elevation to them, so that affects your ability to, collide or not collide with certain things. There's so much to think about. And that's just, as far as how you're storing the world affects how you actually wind up interacting with it. Because none of, like, you don't need to know what the property, you don't need to have the ability to change the properties of that grid, like in the Minecraft example, if you're never going to allow the player to build things, right? The necessity to be able to do that and say there's nothing here at this block versus you don't have to worry about even the block having those properties of whether it's wood or it's rock or it's coal or whatever. The gameplay dictates whether you care about any of that, right? This my brain's hurting a little bit trying to think through all of this. I really hope that someday we'll get like a really avid game programmer that can sit in and watch these and help educate me alongside these things, because I can see at the things I can kind of see where Casey is driving with this answer to this question that he's giving, where he's saying, hey, this idea that you're going to try and save space by removing tiles from the tile map that you're storing in memory, it's not really going to do you any good in the end. Like storing that tile map and then having to deal with its removal or adding new tiles like on the fly while your game is running doesn't really pay you any dividends unless that tile is just off and away somewhere in a world, in a part of the world, or in a separate world that you're just not going to be accessing frequently. I don't know. One step at a time, one day at a time, right? I think I got time for one more question, and then I got to go. One more question and answer.
So Sean McGrath suggests doing FP:fast, which is let's take a look here. Remember, I was asking earlier on the stream, I was like, can we get this guy to start outputting for that floor instruction? I kind of wanted him to output a better thing for floor than it was outputting, and I felt like the compiler could have been doing a better job. But when we actually went and looked, as you can see, it's still calling floor. There's the call to floor right there. So what I was hoping to do is basically to make it so that we could have the compiler output something a little more sensible than the stuff that it is outputting at the moment. And so the commenter is suggesting to do FP:fast, first of all. Let's see if that works. See if that has any effect there. Go to disassembly. Okay. Let's see. There it is. Yes. Yes, 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 yes. This is what we wanted. This is much better. Now you notice we are not getting any more floors. Yes, thank you. FP:fast. Remember I was saying there's a way to like tell it not to have floating point consistency. So let's take a look at that. That is the thing that we wanted right there.
Okay, he's going to go off and look at some documentation, and as exciting as that all is, I'm sure we'd all love to watch him pour over more documentation. I'm going to go ahead and look at my notes and say that I already talked about this, more descriptive naming for the tile relative X and Y into the tile. Inlining functions and debugging, talked about that a little bit, and then there's this thing that he brings up all the time that came up in the previous day's Q&A, which is his style, his self-described style of programming that he calls compression-oriented programming. And I think it's something I've always aspired to do because I think I'm too dumb, really, to do it any other way. Like, object-oriented, strictly object-oriented, or strictly functional programming, or really strictly any kind of programming that says you need to write the code a certain way, never really made sense to me, because it just turns out that there's multiple ways to solve a problem always, and you can build a good product that is backed by a good engineering and good code written in 2 different languages, and one is like mostly OOP and the other one is mostly functional, or maybe there's a blend between them. There are people building good products in Go, Ruby, whatever. It's all about what you feel makes you the most productive, because if you're feeling productive, there's a good chance you're being more productive, although what are you being productive at is the thing that you really want to measure, right? What is the actual thing that you're getting done? It's value, it's output that actually helps, accomplish the actual thing that you want to do. And maybe the thing that you want to do is just mess around with fun programming language features all the time. That's a reasonable thing to do because it's fun to mess with features and see what happens. But if, there's a business that has business goals to make revenue and profit, then you better make damn sure that you're not just idling and doing something really just useless and not contributing at all to the business, right? You want to be doing something that's, making things cheaper to run, faster to run, easier to maintain, easier to test, all of these things that go into making a business more effective at doing what it does where software is concerned, right? So strictly any kind of programming methodology, test-driven development, never mind the actual like programming language style that you're sticking with. It just never made sense to me. But this notion of compression-oriented programming, it doesn't say that you code a certain way. It doesn't say you only use pure functions. It doesn't say you only use object-oriented stuff or only procedural stuff even necessarily. But that is, the kind of style that I've just kind of wound up going with, where it's like I just like following a nice procedural set of steps, because I'm not smart enough to do all this crazy async await nonsense. I mean, I do it when I have to deal with it, but I deal with it as little as I can because I just find that it doesn't help me reason about the problem I'm solving any better than whereas if I didn't have it, and most oftentimes it makes it harder for me to solve the thing that I'm actually trying to solve. But this compression-oriented programming approach that he talks about, where you just write the thing, the simplest thing that does the thing, and then as common pieces emerge, where you're just finding yourself writing the same thing, you just pull those pieces out into one reusable procedure or function, whatever method. Pick your nomenclature depending on what language or ecosystem you're using. Whatever feels good, whatever sounds the coolest. Procedure, maybe that sounds stale and boring. Maybe function too is too mathematical and boring. So method, I call methods on my objects. Maybe that just feels hotter. I don't know. But what I try to do, I think, is I wind up, if I write the same code twice, I don't necessarily say, hey, this is a pattern, I got to pull this out right away and make it a common thing, because 2 things can emerge that look similar in code, but the actual pattern has yet to reveal itself. It's once I get to that 3rd time, once I'm doing something for the 3rd time, then I'm like, okay, that is a pattern that can be reused in a single function. And that is my soapbox, however small and insignificant it may be. But I had a note I wanted to add here based off of I wanted to make a note to myself to look into learn more about Odin's compiler switches, right? Because that just seems like something super valuable to have a better understanding of. I know just enough to do what I've done with this project so far, which is not a whole lot, just enough flags to build a project. And then there's, get a to-do list going, get a project to-do list together, and add to it as needed and as I desire to do something new. And that is get a debugger working with Odin and someday work on a level editor. And maybe it's just, it winds up being a very limited in scope level editor, but we'll say with specific functionality or capability in mind. Let's just say functionality is in mind. And that's all I got. Yep, dry and kiss. Those are basically the only things that have stuck with me, I think. All the rest of it, solid, clean code, whatever. Anything else has really just, like, I couldn't even recall to you all of the principles of solid. I think one of them is like open close principle. I never really understood what that meant. I think injection is in there, like dependency injection, or maybe that's the last one, the D in solid. I don't know. But dry, do not repeat yourself. But again, I don't know that I'm necessarily repeating myself egregiously until I've hit that, magic number 3, the third time I'm writing something out. Now I've got a pattern, and I can stop repeating myself and turn that into something reasonable. And then kiss, keep it simple, stupid, if I can even say it right. It's so simple, but I can't even say it right the first time. Always pays to keep things simple, and I think that's what's really been a lot of fun about Odin, because it does keep things so simple. It just makes it really fun to write code, because you're actually doing the thing you want to do. The language kind of gets out of your way, and you're just off and you're building the thing that you want to build. So we'll keep doing more of that tomorrow, and I'll see you then.